Are we ready? Last master class. So same story as before. We're going to go for about 45 minutes now because I think that's about how long it's going to take me to get all of the results together. So I'm going to turn this over to Ben and Britt, and they can talk about the case. Y'all ask them. Y'all have fun with it. And I'll see you back in about 45 with the results. Thanks, everybody.
All right. So, yes, the same structure as last time. We've swapped places, so I'll kind of walk through some of what I've set up. I did try to create a file to illustrate a few points. I think this case being a map case kind of had a different feel to it. So talking about some of those concepts. And then I also wanted to kind of lean in on a little bit of what I think we touched on earlier, but the idea of kind of choosing different types of setups. And so I've actually, on some of these problems, come up with a few different ways of approaching it and how I thought about switching up from more of like a column-based format to some single cell formulas. Want to touch a little bit on a complex let, which has a lot of characters in it. Ben thinks it's a fun one, and then even show you a little bit about setting up a lambda formula, just because that's something that as you continue to get kind of more engaged in competition, you might find useful at times. So yeah, we'll dive into it. All right, so, of course, basic premise of this is it's all about the duck hunting, and it's about this map, and you've got ducks flying in, and you're trying to figure out both, in the earlier rounds, it's all about finding out where they are, and then as the levels progress, you're trying to figure out based on, where the hunter is targeting and how far away that duck is, or even further on, you get like 20 ducks on the screen, you've got to figure out which is the closest duck and how far away they are. So lots going on with this case. So I was going to start kind of walking through a little bit of touch on level 1. I'm going to spend most of the time, I think, on level 4 because it kind of combines several of the concepts, and then go through a few bonuses, and we can touch a little bit on level 6 and 7 if there's some interest. So for level 1, we'll go back off that formula. Come on. Well, now what's happened to my mouse? That's weird. Okay. So for level 1 and level 2, the basic concept is identifying where the duck starts and how many cells it's flowing over. So for these ones, I very much leaned on and through a lot of them, the indirect formula and then the row and column formula. So the indirect will allow you to reference something based on a text input, essentially. So in this case, the text input is a starting cell, A13. The indirect by itself is just going to tell you what's in cell A13. And then the column formula is going to tell us what column it is. So putting those concepts together, it can tell me that, hey, if I'm starting on A13, that's column 1. And then similarly, if I look at the row A13, I take the row of the indirect, and that's row 13. And then from there, finding the new location is, of course, just taking the existing column, adding the number of seconds the duck has flown, and then we are combining to get the cell reference again using the address formula. So we've got the row, we've got the column set up as different formulas, and then the 4 just gives that the reference without the $sign, so the relative reference there. So starts kind of easier. Did anybody else use the indirect and the address formulas? There's some ways you can solve it with offset too. Any other functions that y'all leveraged for this one?
So kind of like how XLOOKUP was the key formula on the previous case, this case, the indirect formula is your key formula that you're going to use pretty much on every level. And it's a big one on maps, which are a big thing that we see across our cases, is mapping and using the indirect formula. So that's a very important formula just to keep in your brain, in your back pocket.
All right, so jumping ahead over to level 4, because I think this is where it gets interesting. The first 2 levels, you're starting on the left, you're flying right. Then you're starting on the right, you're flying left. Level 3, you're being told to choose left or right. Level 4 is where it starts to really get interesting. So I did the same thing as on level 1. We've got the column start, we've got the column end, we've got the row start. That's all the same as before, using those indirects, using those columns, using the summation. I'd say the additional difference is in starting to also integrate the direction that the bird is flying. So we know that if the bird is starting in column V, that they're going to be flying left and otherwise flying right. So what I've done here is create a multiplier that's just either 1 or -1 based on that starting column. And then I'm able to determine how many columns they move just by multiplying that by the number of seconds, which will come in handy later as well. So my column end just becomes, hey, where did we start? plus the number of seconds times that direction multiplier. And then I end up with that column in that row. The row doesn't change ever with these. So that's going to tell me where the bird is located. The next piece of the puzzle in this question is I've got to know where did the hunter fire, and then how far away is that from where I am. So to figure out where the hunter targeted, it's using those same functions, using the same indirect in column, indirect in row, but on the hunter target. And then the distance, they've defined distance. This is one thing that comes up in map cases a lot, is the distance. There's just several different ways that we can calculate distance. So I've seen everything from, hey, we can add up the number of rows and the number of columns, because you can't move on the diagonals. So you add the row difference, you add the column difference, that gives you distance. This one is kind of similar to where you can move on the diagonals. So it's always going to be just a maximum of whether, based on how many columns you are over and how many rows, you always take the maximum. That's assuming you can move on the diagonal. I've seen some use of Pythagorean distance as well. So you have to do the a squared plus b squared equals c squared equation. I've seen some other, from some of the eSports cases as well, they've also tried to add some additional complexity. So different ways to think about distance. You always want to make sure you're determining which one it is. But in this case, it is just, it's that distance that allows diagonal movement. So it's the absolute value of the column difference. So I've got the column target minus the column of where the duck was, and also the rows, and then I take the maximum of those two. So in this case, that bird ended up in column 19 versus the hunter target, so that's one column over, but there's 6 rows difference, so 6 was the distance. So it's kind of like the basic setup initially. I use a lot of column-based approach when I'm just running through things quickly, because it's really easy to throw out a bunch of columns. But what I noted with this case is that as the levels got progressively more difficult, that sort of column-based approach is not easy to expand. So in a later problem, we'll get to have 20 ducks. These columns work well for one duck, but trying to copy that over 20 times, it's not going to work, because we got several columns that are needed for each one. So that's kind of what I noted here, and wanted to show how you can kind of translate that into a let. Has anybody used let? No. I love let. It is one of my second to X lookup. Let has become my favorite thing. And I use it probably you can do a lot of really complex stuff with it. There's lots of rows, but it's not any more complex than what's happening here. I've essentially taken these same columns that I set up, but created one row in each. So we'll see, okay, this direction. Okay, I'm looking at that A or V, 1 or -1. That's the exact same thing that I'm doing in this formula here. I'm getting that column start. So it's just defining, within a let, you define a variable and you give it a formula. So for each column I had before, I essentially have a row in this let formula. So you're doing all the same things. And a lot of times, this is how I learned how to build let, was kind of you take it, you build out all your steps, and then you combine it into one. So it does the same logic and kind of the same order as what I did in those multiple columns, puts it into one. And that is really beneficial when you want to be able to copy it over. So I'll use this one a little bit later, to where I can kind of copy it over to use for each bird and easily find for each bird what is the distance for those ones, by just taking this and replacing my start with those 5 different or 20 different birds or whatever.
A good way to think about a let function, kind of going back to how we did data tables earlier, it's pretty much the same thing as a data table, but you're putting it into one function as opposed to writing it all out and then creating the data table at the end. It's just putting it all the steps you've done into one function and into a single cell.
Yeah. And I'll also say I don't throw this down a lot in competition yet. I am feeling more comfortable with lets, and I'll use it up to a certain extent. This is probably the most complex let that I would ever think about writing in a competition, and it still is risky. And I've done this, and it's been one of those risky moves. If it can be helpful when it works, because then you can have it, you can plug it into other places. But if you get it wrong, or if you get stuck trying to troubleshoot it, then you can waste more time. So it's one of those things that I'm still in this process of kind of learning, getting really comfortable with. I'll use it some, but I do tend to default over to the data table solution that Ben showed. You'll see I kind of have extra tabs for level 6 and 7. I did take that data table approach because this was getting too complex, but wanted to kind of show how it would take those multiple columns that you may have written out, and you can combine it into one to, use in more places. And I think another thing that I wanted to show, so I was thinking through, as I do with my practicing, because you'll never see this exact case again, right? This case has been done once, I'll never repeat it. And so the important thing when practicing is to say, okay, I'm going to take a case. I want to see, are there perhaps different ways that I'd think about it? So when I was going through this case, I was like, well, what's some other different functions I could think about using here? Because that's how I learned to just think about things from different perspectives. So one other option I looked at was like, okay, well, how can I leverage the offset function here? So I had used the indirect and then the row and column, and then I had done those extra steps to add the distance that it had moved. So in this case, it's kind of like, it starts the same. So this indirect G175, that is just going to say, okay, I want to create a reference to cell V8 in this case. And then the offset function says, hey, I want to move a certain number of rows or columns from that. So we know that the birds always fly just straight across. So we're not going to change the row. So bird starts in V8, it's going to end in row 8. So 0 is my offset for the row. But my offset for the column, like we know the bird is going to move, and it's going to move based on how many seconds it's flown and the direction it's flying. So I'm using that same direction multiplier based on the A or the V in the seconds, and I'm using that to say, okay, I'm going to start in cell V8. I want to offset that, in this case, 3 columns to the left, and then give me the column of that. So it's kind of another way to think about how can I move from one cell to another. And the offset is another one that comes in handy with some of the map-based cases. So you've got a certain cell, you want to say, what is the thing that is a few columns down, a few rows over? Another thing that offset can do is it can return a range of cells. So the additional parameters within the offset that are optional are a height and a width. So by default, it's going to give you one cell. But if you modify those height and width parameters, you can say, hey, I want to shift over one column and one row, and then I want to take a 3x3 area. So there have been some map cases in the past where it's been handy to say, hey, I know that I want to target a certain cell and then all the cells around it. So I'm going to, offset a certain number or stay where I am and do a height and width of 3 or something like that. So offset and indirect, I think, are very handy functions when you're thinking about map-based cases. Any questions or thoughts on this level?
For those height and weights, you said, so it targets the center cell and then fans out from there? Does it target the top left?
It'll start the top left. So if we think about...
So it'll extend from the left to the right 3 and then down 3 in that case?
Yeah, so let's say I wanted to, get a 3x3 area. That includes this cloud. So if I take this and I offset it 0, 0 columns, but I take 3 rows and 3 columns. Oh, why is it spilling? There we go. I had some extra stuff in there. So it's going to return. It's going to say, hey, I want to get 3 high and 3 wide from that starting cell with, I'm not shifting the row or column at all. So it gets that blank, it gets that C, that 0. You can also, if you want to target a certain cell, you can say, hey, I'm going to target the cell, I'm going to offset -1, -1, and then it's going to pick up this range here. Anything else on that one? Okay, I'm going to show a couple of lambdas because I think they're fun and they are handy in some of these map-based cases. So one thing I thought too, and I didn't pull any of my sort of pre-built lambdas. Lambdas, if you're not familiar, are kind of just ways of creating your own custom functions that you can use. And in some of these eSports cases, a lot of the folks that I've got a file as well, I've got some pre-built stuff that just is things that come up a bit. They're meant to just give me some more flexibility in ways that I like to work. And so a lot of folks kind of bring them into a workbook and then you can use them. So for instance, I've got in my Lambda workbook, I've got a distance calculator where I can feed it a starting cell and an ending cell, and I can tell it, hey, I want to calculate it based on that diagonal distance or the no diagonal or the Pythagorean. I can feed that in and it'll tell me the distance. And that's just something that I've built for myself. And I didn't pull those in there, but something like that is something that, you may find handy. You might see certain patterns emerge as you see the cases of things that you want to build a function around that you don't have to repeat every time. So I just played around with kind of creating one for this case that ultimately I created this function called distance where I fed it a start and a location, start and end, and it just gave me that distance of 6, same as above. And then you can feed it in and use it elsewhere. So it kind of starts on a lot of the same premises. I haven't used this one a lot. I was playing around with it. The cell function can get you different types of information about a cell, but the address is one of those things. So instead of having to like parse out your row and your column and then use the address formula, you can use this to say, hey, I'm just going to give you a name of a cell, and I want you to give me what that address is. And so it does it. I hadn't played around with it too much, so it was giving that absolute reference with the dollar signs there, which works fine for what I've got. So I was playing around with that. And then I created, so this is the Lambda formula that I wrote out. So I said, hey, and when you create a Lambda, you first give it kind of some parameters that you're going to generate. So the things that whenever you start a function and you're typing in, you get a little drop down like, hey, you need to feed in these items. I was like, hey, the things that I want to feed this formula, this custom one I want to build, are a start and an end. And then you define the formula for that. So this is just doing another let where I'm like, okay, well, I want to grab the starting row from whatever I feed in as the start, whatever I put in, if it's A26 or V8 or whatever it is, it's going to just parse it out and give me the row. It's going to give me the column, same as before. It's going to do the same thing with these, whatever I feed in for that end cell name, row and column. And then it's going to calculate this distance, kind of same as before of, hey, I'm going to look at the starting versus the ending row and the starting versus the ending column. So this is the Lambda formula. You write that out, and then in this case, I wanted to be able to actually evaluate it. So these are the two parameters. I'm saying, hey, this is my start, and this is my end. This is kind of a way of building and testing it. And so I can see that's working properly. And then what you ultimately do with that is, and I did end up ignore most of this. I did end up pulling in my other stuff. We can ignore everything but this distance one. So I created a new name. You paste in that Lambda formula, and then all of a sudden you can use it just like any other formula. So I typed it in here. I said, hey, distance in my two cells. It looks very simple, but behind the scenes, it's got all that additional logic. So I think with Lambda formulas, it's not something that you want to, just like copy a specific formula that anybody else has written. Like the formula that I wrote here for this may or may not be useful in the future. But if you are finding some of those typical things and you're kind of writing those same formulas over and over again, you may find it useful to kind of build yourself out a function that works the way that you want it to work, that helps you alleviate some of the pain points that you see.
Yeah, and you'll see a lot of times if you watch the videos online of other people completing these cases, or if you go to Vegas and compete, all the professionals, they all have their own Lambda libraries that they bring in every time they do a case. It's a great way to think about it is when you're taking an exam and your professor says, hey, whatever you can fit on one sheet of paper, you can use that on the exam. That's a great way to think of Lambdas. They're ways that you can build out your own functions and save you time when you're doing the case battles themselves. So they let you use them when you're doing the cases in Vegas, but they're great ways for you to save a lot of time.
Yeah, but I would say it's important that you build them yourself, or at least get really comfortable, because you don't want to end up in a situation where you do not understand the nuances of how it works. Like you can write one that works for what you need to, but it might have fringe cases where it doesn't. So just wanted to show you that I do not typically write new Lambdas during competition, but it is something that I've spent some time working through, like what are some of the common things that we see. Like there's a really common trend in some of the bonus questions to be like, hey, what's the thing that shows up the most in a given list of items? So I've written myself a Lambda that's called most common, and I've just plugged in the data set and it just tells me what is the thing that shows up the most, just because I've seen that. And like I've customized that to my needs. Got the distance ones. I've got some ones that will feed me out certain information. I've got one that's like a letter count. So that bonus from earlier where it's like, what's the most common letter across all of the level 7 answers? Like I can just plug that in and it tells me what's the most, or what, I can look up each letter, what's the most common letter, stuff like that. But this is kind of just an example to show like different approaches in varying complexity. I'd say when I was going through this, it was definitely just the basic column-based approach, kind of like building it out, working to understand the concepts. But then what I was finding, and it happened a couple times in this case, that strategy had to switch a little bit. So that multi-column thing didn't work with multiple ducks, and then some of even the single cell formulas didn't work the way that had been set up, and I had to switch over to data tables. We'll switch over to the bonus questions for a few of those. So the first one was a fun one. It's probably one of the earlier kind of tips that I picked up from watching, I think it was Dear Med, but In this case, it's asking for how many cloud cells are in the scene. There aren't that many. It probably wouldn't take you long to count them up, but sometimes when we have larger maps, so there's just more things going on, you need kind of a better, more formulaic way to figure out how many cells are a certain color. And most formulas don't touch color. You need macros to kind of get into that space. But one little handy trick that I've learned is the find and replace by cell formatting. So in this case, I only care about the cloud cells. So it'd be nice if perhaps those white cells had a 1 in them. And it'd be really easy to do this. So you can open up the find and replace screen. And then I don't know if anybody's familiar with this, but this choose format from cell. So you can just come in and select, hey, I want this, this white cell. And you'll see it pops up with the preview in there. You can actually go in, you can modify things about that. So what it's chosen is this fill color right here of that white color. So I've got that selected as my find what. I'll select my map and I want to replace that with 1. And then when you replace that, you get a bunch of 1s in there. Where did it go? There we go. And then a few different ways, of course, to find that, but you can put a 1, you can do a sum, you can put a letter, you can do a count if, and all of a sudden you get those 40. Anybody's familiar with the find and replace by cell format or used that before? Anybody count this up manually? All right. So that was bonus 1. Bonus 2 was getting into, so level 3 had that mix of ducks that were flying left to right. So it's just looking at, well, how many were flying from left to right. So we know that that is based on how many started with the A. So I used the same kind of wild card trick that Ben showed earlier. And I did a count if and said, hey, I'm going to look at those level 3 starting positions. So I just highlighted all of those. And I said, hey, I want to count how many of them meet this criteria. They start with A and they have anything after them. So A and then that star. So that gets me that count there. Again, probably not a lot. If you want to like count them up manually, it'd be pretty quick to see how many A's are. Again, with a longer list or more complexity, not really possible. All right. And then, yeah, so bonus 3 was kind of one of those, hey, what's the thing that shows up the most common type of exercises? So, like I said, I do have a Lambda built. I didn't use that here. I kind of went back and did it basically. So a lot of times what I've said it before, if you're trying to pull in information from across multiple cases, is a VStack. So I knew in this case I wanted to basically grab a column of data that hunter target, so we can see where the hunter targets starts in level 4. So we want basically all of this. We want all of this. There's a hunter target here, and there's 2 different hunter targets in level 7. So all you need is that basic information, which you can copy and paste as values. You can do a few different things there. Got smaller. But yeah, so I just built out a VStack so that I could stack them all up into one range for easy reference. I did that same unique thing that Ben showed, so getting a unique list, and then doing a count if. And in this case, I was using all those kind of dynamic arrays, so my VStack becomes one spill array, and then in my unique, I can reference it by using that, the hashtag in there. I can reference that in my count if as well. And then ultimately I'm doing that X lookup, and here again is where I did that. Like, hey, I know that there's not possibly a number that exceeds 9,999, so I'm looking that up and I'm finding the exact match or the next smaller item, and I'm returning the name of the cell that shows up. So, any questions through those bonuses? All right, so those are some of the easier bonuses. So let's look at some of the more complex ones. So level 5 of Duck Hunt starts to introduce the fact that there are multiple ducks in play. So 5 ducks are flying. They're all starting at the same time. We are waiting a certain number of seconds, and then the hunter is targeting, and we want to know the distance to the closest duck. So to do that, we need to understand how far, where did each duck end up, and how far is each duck from the hunter's target, and then I want the minimum of those values. So that single cell formula that I had created before worked out really well because I was able to, let's see, I'll start with this one. So this is that exact same single cell formula I showed you before. So it's got all the things combined, stacked it into one. And I just said, hey, I'm going to copy and paste that over 5 times, each time shifting over for the duck. And that will return me the distance. So I know that duck 1 is 4 cells away, and duck 2 is 3 cells away, duck 3 and 4 are 10 cells, and duck 5 is 5 cells. So all I need now is the minimum of that. And then that's pretty easy. If you build that on the same row as your example, you can copy it down and get to that for each one. But then I also incorporate a couple of solutions where, depending on what you had built, so if I had built that distance lambda and was using it, then I'd be able to kind of combine those things together and say, okay, I'm going to input the 5 different ducks as my start. So I'm selecting this range. So all 5 ducks. I've got the number of seconds that they've flown. I've got the target. And then everything from there on out is going to calculate based on each of those starting locations. So we've got the direction multiplier. It's going to look at each start. It's going to determine for each one, is it a V or is it an A? Is it a -1 or is it a +1? And then it's going to find that location. Here's where I played around with that cell and address formula and just bringing that back as the cell location, because when I wrote that distance lambda, it needed a cell reference to know how far. So it needed an input of a cell reference and an ending cell reference. So I just use that to say, hey, I want to get the cell address, and I want to take each starting location, and I want to offset them by the number of seconds times the direction that they were going. And then I'm going to use this distance lambda, so I can use the lambda within the let formula. And so it's going to calculate for each one of those, what's the distance between each one. And then my final parameter of the let is, okay, what do I want to output? So I want to output what I calculated for distance here. And because my input was those 5 cells and nothing along the way combined those, it kept them separate, and it calculated, hey, you've got, 5 different distances, which are the same distances I calculated if I did that single cell formula and just copied it over. And again, can kind of take the minimum. And if you're fancier, like I had created that, that lambda with the target distance, which kind of combined everything. I'm like, I would never actually do that in competition, but you could combine everything into one and then try to apply it. But I would say that did not end up working for the next level because you need not a distance anymore. You need to return a duck location. So a few different things you can play around with there.
This case is a great example of how each level continues to build off of the previous level. It goes start in level 1. It's very simple, just your column address, and then it continues to build off of it each level proceeding and adds a few more rules, but you're building off of what you've already done. So you can save a lot of time too by copying what you've done in previous levels and applying it to the new level as you continue to go.
Yeah. And some of the methods will be easier for copying down and then extending. So like these columns work up to a certain extent, but then the data tables, especially that Ben showed earlier, like those, personally, I find those easier to kind of build on, which is what I did for the later level. So after level 5, level 6, I think is a large leap in sort of the complexity there, because now you're dealing with 20 ducks. But the complicating factor is not just more ducks in the equation, but you also have this concept of each duck is starting 1 second behind the last. So while the first duck will have flown for 22 seconds before the hunter fires, the second duck will have only flown for 21 seconds, third duck for 20 seconds, and so on and so forth. So you have this dynamic of now you need a different number of seconds, a different sort of offset or distance traveled for each duck. And I think originally when I play around with it, like I do have a single cell formula that I built and a complicated let that works. I think the only thing I'd highlight from the let here is when you start building these really complex ones, like troubleshooting becomes the really difficult part. But one trick that I got from, I think I stole it from Dermot Early, is this concept of like building in a check. So you can define a variable as your check, and I'm just v-stacking like all the different pieces so I can actually see it and see what each interim step is calculating. And so I output that here so I can see, okay, well, I defined this start thing. Okay, well, here it is. I defined these seconds, and I can see, okay, the number of seconds each bird is flying. I've got this decreasing sequence that starts with 22 and then decreases by 1. I can see the column that each bird is ending in, because each of those steps could be a place where something is going wrong and I need to troubleshoot and tweak and adjust. So that check is really helpful. But I'd say, and especially in competition, I would have definitely defaulted to jumping over and building a data table setup. So this is kind of my standard setup. I usually have the game number in here. I always highlight it yellow just for easy finding. This is the thing that if you change this, everything in the model changes. So same concept as what Ben shared is I've got these, and these are some lambdas and some stuff behind the scenes, but essentially they're X lookups. They're essentially X lookups that are bringing in all of the case data that I need. In this case, I need 22 columns of things because, I need 20 ducks, I need a hunter target, and I need a number of seconds. And all that's the starting input. And then I start building out all the pieces. So I'm okay, I needed to figure out, well, how much distance do they travel? That is the number of seconds that they've flown. Well, I know that's going to be, it's always going to start at whatever the input is. And I need 20 of them. And then I'm going to do this step change. So the sequence will start with 22. And then for each version up through the 20 pieces that I want it to output, it's going to decrease by 1. So it's just going to bring out this thing that says 22, 21, 20. And there's 20 of them. So the last one is a 3. So that's going to tell me how much distance they traveled before we apply the direction multiplier. I've got kind of the same things I had before, but it's now laid out in this sort of template. I'm grabbing the column that each bird started at, grabbing the direction that each bird is traveling, calculating where they're going to end, again, using that direction, that distance traveled. And then I've also got to account for, is this bird out of bounds? And so this is where I was okay, I need to know, is the bird in column 1 or by the calculation less than column 1, which doesn't even exist, or is it greater than column 22? And so this bird flew for 22 seconds, started in column V, so he's going to be out of bounds by the time the hunter even shoots. So I've got this logic that just tells me, okay, are they out? Because I want to ignore them if so. And then I've kind of got the same thing, bringing in the target, bringing in the column and row there. And then I calculate the distance that they are. We've got to figure out which bird is the closest. So the distance is going to be that same concept of I got to figure out the row distance and the column distance, and I've got to take the maximum of those. And I do want to ignore it if it's out. So I've got this if logic says, hey, if this thing is out, so again, Excel treats ones and zeros as true or falses. So if K10, which basically is telling Excel if K10 is true, if it's a 1, it's just going to return 999 because I want to ignore it. I just want to give it a fictionally high distance. And then if not, it's going to calculate. So you'll see these first 2 birds get those 999s. They're out of bounds. And the rest of them get a distance. And then I also bring in, because I need that ending cell. Because what I'm going to ultimately do then is I'm going to look up I want to know which bird is closest. So which has the smallest distance. So I'm looking at an X lookup of 0 along my distances. I want to return that ending cell. And then again, I'm using that approximate match. So hey, if there's not a bird that's 0, I want to know which bird is closest, so the next highest value. So it's just looking that up. And then, like Ben showed earlier, it's got that data table where I've got, hey, these are the levels, 101 through 120, that are in this round. I've calculated my 1, and then I set that data table up, which just calculates it for all of the rest. So that data table setup becomes really handy for one like this.
This is one of those levels where it's key to make sure you read the instructions carefully, follow along with the examples, make sure you do it as the example shows, and that's a great way for you to measure yourself and make sure that you're including all the rules that you need to include in your final answers.
Yeah, I usually bring in that answer for the example right here so that I can easily see it and know if I'm on track or not. Any other questions or comments? All right. And I did want to skip it. So one of the bonuses talked about how often in level 6 is the bird behind a tree. and Ben, we're comparing notes, and we approach this in two different ways. So, a couple of things, we essentially just need to know which birds are at one of these cell locations at the time that the hunter fires. So we've already done the hard work in this setup by knowing, hey, I know where all the birds end up. So I just need to check, are these some of those cells? So one thing, I think the way that Ben set it up was he essentially had this map, and we put the ones in where the trees are. And so we can use that same concept of a indirect, only this time we can go across to a different tab and pull that in. So this is an indirect where we're saying, hey, I want to go to this scene map tab, and then I want to go to the cell that's here. So we're combining this sort of text piece, because I know I'm always going to this tab name. So that's the tab name. It's important to have, if you've got spaces in the tab name, you've got to have the single quotes around it. You've got to put the exclamation mark. So all of those pieces are pretty standard. And then I combine that with the cell reference. And so it's just going to tell me what this is going to return is just whatever's in that cell. So we'll see cell U11 on here, right over here, just has nothing in it. So it's going to return a 0. But if we get one of those cells that does have a tree, so like F22, see F22 is right here, it has a 1. So it pulls those back. And to get the number of trees, I essentially need to count up, well, how many times does a 1 show up? Or whatever you put in there. Could have put a T for tree or anything. We just got to do a count if or a sum to figure out what we're going to pull back. So in this case, I'm just doing this count if it's a 1, and that's how many times these birds are behind the tree. So again, I'm leveraging the data table. So one other thing you can do with a data table, in this case, I've got 3 different things across the different bonuses that I want to pull back. So one is like the level 6 answers, and then this is the number of trees that I want to pull back. And so you can set up a data table on not just one return, but you can actually set it up on multiple. So if I highlight both of these things, it's going to recognize that these are 2 different outputs that I want to return for each level. And so you can fill that in. I got that right. All right. And then it's still the same thing of, hey, all of my inputs are in a single column, and this is where that input goes. And so I hit OK, and it populates it. So we'll see, across the different levels. Sometimes I have no birds behind trees, or 2 or 3. So I can calculate it out that way. So I found that a few times, I think, across cases where go back to do bonus questions, and I realize I need to pull out like an additional thing from my data model into the data table. So I'll add those in and just recalculate the data table. So again, like having this set up and keeping that tab sort of in place for those future levels and just copying it can help, because you can always go back and get additional information from it. And I think the way that so that was more of like how Ben had done that tree logic. I did something I think a little less eloquent, but I essentially created a list of things where all the trees were. So I did a few different steps of work to calculate, or to get to, well, it broke when I added more stuff, but essentially to get to this list of these are where all the trees are located, and I just made that into a named range. And then I did an X match to see, okay, is this ending cell in that range, in that list of tree locations that I had? So X match will return the position location. So if it finds that S19 in the first position, it will turn a 1, turn whatever it finds in. And I just wanted to know, is it a number? So I'm doing this X match. I'm filtering out the errors, and then I'm just saying, hey, is it greater than 0? So does it exist in that tree list? Essentially, a few different ways you can get at that. Any questions so far? Anything you want to revisit? Level 7's a lot of fun. All right, so level 7. So the big thing in level 7 is that we're going from, so level 6, we of course had 20 birds. They're all starting at different times, and the hunter's firing, and we want to know which bird is closest to where the hunter fires. Level 7 then says after the hunter fires the first time, he's going to fire again, But in between that first firing and second firing, the birds are going to scramble. So hunter's going to fire, and then after that point, the birds are going to look for the nearest edge, and they're going to start moving at double speed. And they're going to travel how much ever distance in the number of seconds between the first fire and the second fire. And then you ultimately want to know, I think the ultimate output was the closest bird still?
Yeah, closest to the second fire.
Closest to the second fire. Yeah, so we're still kind of looking for that same location. And so this is where that sort of having that data table helped out, because I was able to copy the level 6 over and just get to level 7. And so all of the logic, I think, essentially up through here is the exact same as 6. So I copied that and I said, okay, now I know where each bird is located after the first time that they fire. So in this case, they travel quite a lot, but duck 11 is now in cell B15, duck 12 is in T21, etc. And I'm going to have kind of new logic for determining where they're going to end up after that. So I'm going to have a new direction, and the new direction is essentially looking at, because we know this map is, I think it's 20 cells wide. So the map is 20 cells wide. So if it's through column 10 of that 20 cell range, the bird is going to go left. And if it's beyond that, it's going to go right. So I had to add in logic that just said, hey, give me the column number of where they were. And if it's before or equal to column 11, which is that 10th column in the map, then I'm going to give it a multiplier of -2, just to show he's going to move 2 cells over to the left for every second that he's traveling. Otherwise, he's going to go to the right. So just added that in for my new direction, and then did kind of very similar logic. So again, like I was able to copy and paste and replicate the existing stuff and get a new, then my starting column was the ending one from the prior step. The direction was, I duplicated that logic. My ending column is going to be that starting column from the second step, plus the direction that they were traveling times the number of seconds that we traveled in between the first and second shot. And then I'm kind of replicating that same thing of saying, hey, I need to check if they're out of bounds, I need to figure out the distance, and I need to then figure out the cell. So it's like a lot of same concepts, but the hard part was making sure I had that location of where they were in between shot 1 and shot 2, and then doing that calculation of like which direction they're going to travel next. So I thought that was a lot of fun. Something a lot easier if you had set up level 6 in like this data table structure, which is not how I set it up initially when I first worked through it. But that's, again, where it can come in handy. Yeah, and then bonus 5 I thought was nice and tricky because the answer was actually 0. Like, there's no way that's right. But it is. So bonus 5 is just saying how many times does the hunter actually shoot the duck. So the logic had to be built out a little bit differently for each level. The only ones that mattered are, of course, where the hunter is targeting. So level 4, I basically was saying, well, was the distance, because all the answers were distances. How many cells away was the duck, the duck from the hunter shot? So if the distance was 0, then the hunter shot the duck. There were no answers that had zeros. So I knew that was 0. Level 5 was the same thing of you were given the distance. So those ones were easier, but then levels 6 and 7, I was able to come in here and I think I just pulled, let's see, and then a couple of steps. So I just counted. So I looked at all 20 ducks and did a count. If the distance was 0, then I wanted to get the count of that. That, of course, was 0. I added that into the data table and recalculated that data table and got zeros across the board. And same thing with level 7. So a couple different approaches because it was focused on a couple different levels.
In the way I approached that bonus, same concept on the levels 4 and 5. I just check if there's 0, there's not 1, so he doesn't shoot a duck on levels 4 or 5. But then 6 and 7, I just copied and pasted the answer values and then set it equal to the hunter target cell. And if it was equal, then that means that it hit it. Otherwise, it doesn't. So just a simple, if it equals the hunter target, then it's a killed duck, otherwise it's not, and it didn't find that there were any. So
That was easier.
just quick, simple
Do
copy
his
and
way.
paste.
See, I overcomplicate things. But yeah, so a few different ways to get it. I like that one. Yeah, I think it's come a few times where there are certain parts that doing things a little bit more manually in the competition actually work out. I think there was one that was on a case in the professional eSports, and it was like you were given a written out, it was like in text, the word 17 plus 3 or something. And so the solution was just to add the numbers together. And if you try to spend time trying to translate the text into an actual numeric value, make Excel do it, it took way longer than just looking at it and saying, well, that says the word 17 and 3, that's obviously 20. So sometimes there are steps when doing them manually, copying and pasting some data over to do a quick like equals check is actually beneficial. So it's one thing too where you can look ahead, like, is building a formula out to do this going to help me in later problems, or is it probably quicker? I mean, same thing with like even just like counting up the clouds. You can probably weigh it of, hey, I could count up the number of white cells pretty quick. Do I need to bother with adding in anything else? And it would kind of depend on what's coming later. So it's another kind of choice to make in the moment, the strategy of where to spend your time.
Yeah, I find a lot of times it's not as complicated as you think. Even though these are complex cases, a lot of times the answer can be found a lot more simpler than you really picture in your brain when you first look at it. So my advice is just try to keep it simple if possible.
But yeah, I think that's pretty much the walkthrough. I don't see Eric in here yet, so I think we need to stall for some more time. So any other questions or comments while we wait for the results? Yeah.
Question, how long did it take you guys to run this case?
Again, I didn't time myself. Same reason as before. See last answer.
I did time myself. I did not complete this one. I got through level 6 in the first 4 bonuses. Level 7 was a tough one.
Did you have something?
Talk about the process you use when you open a case, before you devise your strategy.
Is it the strategy I use or the one that I should use?
Well, let's go with should.
So the thing I probably should do, and I like this is my own like personal development goal, is probably spend a little bit more time at least reading and scanning ahead, because that should help me adjust the strategy. I think there's a balance to be had. If you spend too much time spending time looking at the later questions that you may never get to, you'll have wasted time. Because definitely in the pro league, there's a lot of times I don't make it to all the questions. However, if you are going to make it far enough, it will be helpful to set it up earlier. So like the should is I probably should spend a little bit more time than I usually do, reading ahead, at least scanning, trying to understand the concepts of what's going to build versus what might be a complete break from the prior level. But I'd say what I do a lot of times is just dive in and just kind of start working through levels 1 and 2. Skim through the instructions as best I can, sometimes miss things, and do a little bit of rework as a result.
I kind of do a similar thing where I just kind of, as soon as I open it, and get right to level 1, level 2 as quick as I can. Definitely should spend more time reading than I do. That's probably the most important thing on the cases, is just reading through it, reading the instructions, and making sure you answer the question as intended.
Yeah. It's a good question.
Any other questions?
All right. Well, if no other questions, maybe a little bit of a break while we wait for Eric to come back with results, but don't go too far so that he can gather everyone. But I don't know, it's been a long day for y'all, so.